In this example, we have different variables from x and y. We have t and r. But that's totally fine. Same exact plan. Well, why don't I solve this second one for r? That looks like it's going to be the easiest thing to do. If I add 2t to both sides, I'm going to be left with r equals 2t plus 8. Let's take this 2t plus 8 and plug it in for my r right here. Now we got to be careful when we do this. So we're going to have 3t minus, and then parentheses, 2t plus 8. Now why is it important that I put parentheses around this? If you're thinking because it's like I have a negative 1 out in front and I need to distribute that negative 1 to both, you are absolutely correct. So now I have 3t minus 2t minus 8 equals 9. 3t and negative 2t give me just t. If I add 8 to both sides, I'm left with t equals 17. So there's one of my solutions. Now let's solve for r. If I take this 17 and I plug it into the t there, I'll be able to solve for r. So for this one, I'll have r equals 2 times 17 plus 8. Well, 2 times 17 is 34 plus 8, and that gives me r equals 42. To write this in an ordered pair, let's make sure we go alphabetical order. Now we might have to sing our ABCs here. We have Q, R, S, T. So R comes before T. We get 42, comma, 17. And there is my final answer. Remember, alphabetical order. We do X then Y. R comes before T, so we'll do R before T. This last problem is quite the doozy. We have 3 variables, x, y, and z. Now, how much more fun could you have in a problem than with 3 variables? I don't know. I don't know of a more fun problem we could have. Let's go for it. With these problems, you can pretty much work your way from the bottom up. Right here I have 6z equals negative 24. I can solve for z very easily. I just divide by 6. When I divide by 6, I get z equals negative 4. Now I can plug this negative 4 into this z and this z very easily, and now I have a system of just 2 equations. Let's do that. I'm going to have x minus y minus negative 4 equals negative 4. Let's simplify this. We get x minus y plus 4 equals negative 4, and then I'm going to subtract that 4. I'm going to get x minus y equals negative 8. So there's one of my equations. The other one, when I plug it in, will be 5x plus 2y minus 3 times negative 4, so I'm plugging that in for z, equals 7. Well, negative 3 times negative 4 is positive 12, so I have 5x plus 2y plus 12 equals 7. I subtract that 12 and I get 5x plus 2y equals negative 5. Now I have these 2 equations that I've circled. This is my new system. X minus y equals negative 8. And I have 5x plus 2y equals negative 5. So this is my new system. We can handle this very easily. I'm going to solve this first one here for x. And I'm going to plug that back in using substitution. So here I'll have x equals y minus 8. Now let's plug that in for x into our second equation. So we're going to have 5 times y minus 8 plus 2y equals negative 5. Distribute that 5, I get 5y minus 40 plus 2y equals negative 5. And now I can combine my like terms. I get 7y. I'll add the 40 to both sides. So I'm going to have 7y equals 35. Divide by 7 and I get y equals 5. So there's another one of my solutions. I already have z equals negative 4. Now let's solve for x. If I plug this guy in here, I'm going to have 5 minus 8, which is negative 3, so I get x equals negative 3. I have all 3 solutions. Let's write it as an ordered pair, or ordered triple, excuse me. We're going to have negative 3, 5, and negative 4. And there's my solution. Not too shabby.